Abstract methods in Python. I am having trouble in using inheritance with Python. While the concept seems too easy for me in Java, yet up till now I have been unable to understand in Python, which is surprising to me at least. I have a prototype which follow. In the above code, how can I make an abstract method that would need to be implemented for all the subclasses?
Before ABC was introduced, you would see this frequently. Something along these lines, using ABC. Also read this good tutorial, this URL. You can also check out SOPay.interface, which was used prior to introduction of ABC in Python. This URL. See the ABC module. Basically, you define _metaclass_ equals abc.appmeter on the class, then decorate each abstract method with an abc.abstract method. Classes derived from this class cannot then be instantiated unless all abstract methods have been overridden. If your class is already using a metaclass, derive it from appmeter rather than type, and you can continue to use your own metaclass. A cheap alternative, and the best practice before the ABC module was introduced, would be to have all your abstract methods just raise an exception. Note implemented error is a good one, so that classes derived from it would have to override that method to be useful. However, the ABC solution is better because it keeps such classes from being instantiated at all, i.e., it fails faster, and also because you can provide a default or base implementation of each method that can be reached using the super function in derived classes.
Abstract-based classes are deep magic. Periodically I implement something using them and am amazed at my own cleverness. Very shortly afterwards I find myself completely confused by my own cleverness. This may well just be a personal limitation though. Another way of doing this, should be in the Python std libs if you ask me, is to make a decorator. I didn't write the decorator. It just occurred to me someone would have. You can find it here, this URL, good one Jimmy 2 times. Note the discussion at the bottom of that page re type safety of the decorator. That could be fixed with the inspect module if anyone was so inclined. You can't, with language primitives. As has been called out, the ABC package provides this functionality in Python 2.6 and later, but there are no options for Python 2.5 and earlier. The ABC package is not a new feature of Python. Instead, it adds functionality by adding explicit "does this class say it does this?" checks, with manually implemented consistency checks to cause an error during initialization if such declarations are made falsely. Python is a militantly dynamically typed language. It does not specify language primitives to allow you to prevent a program from compiling because an object does not match type requirements. This can only be discovered at runtime. If you require that a subclass implement a method, document that, and then just call the method in the blind hope that it will be there. If it's there, fantastic, it simply works. This is called duck typing, and your object has quacked enough like a duck to satisfy the interface. This works just fine even if self is the object you're calling such a method on, for the purposes of mandatory overrides due to base methods that need specific implementations of features, generic functions, because self is a convention, not anything actually special. The exception is an _init_, because when your initializer is being called, the derived type's initializer hasn't, so it hasn't had the opportunity to staple its own methods onto the object yet. If the method wasn't implemented, you'll get an attribute error, if it's not there at all, or a type error, if something by that name is there but it's not a function or didn't have that signature. It's up to you how you handle it, either call it programmer error and let it crash the program, and it should be obvious to a Python developer what causes that kind of error there in unmet duck interface, or catch and handle those exceptions when you discover that your object didn't support what you wish it did. Catching attribute error and type error is important in a lot of situations, actually.